Welcome to the second software engineering seminar series. It's my distinct pleasure to welcome Mike Calvo. He's Director of Engineering at Target for mobile and web apps, and he has been an engineer and engineering manager for over 20 years. Mike and the MSSC program have a long association. Mike was a graduate of this program back when I was a student TAing for the courses. He also teaches one of the electives for us regularly. Today is going to talk about DevOps decisions, how managing and supporting operationally web services impacts and enhances services for the clients and applications of the applications at various organizations. And Mike has extensive experience. So without much ado, Mike Calvo.
Thanks, Sanjay. First off, Sanjay mentioned I've had a long history with the MSSC program. I would say that an MSSC program is very near and dear to me. And one of the things I probably love the most about it are the people. It's always attracted people that are eager to learn and to share and to better themselves. And so I see some familiar faces in the crowd, and I give my full endorsement to this program. It's a great program. So Sanjay kind of gave an overview of me. Most of the stuff I'm going to talk about today, I've come to know in the last 3 years during my time at Target. It's been a pleasure to work on something that needs to be scalable and has 24/7 demands. And so for most of my career, I have been an engineer, and the classes that I teach here, I tend to enjoy teaching classes that are really practical and hands-on and where we're actually doing coding, because that's what I've mostly done in my career. Fortunately or unfortunately, the last couple of years, I've turned into somewhat of a pointy-haired person over at Target, and that's been fun. But a lot of this isn't going to be as hands-on as I normally am in my courses. And so for those of you that live in DevOps jobs and do DevOps work, what I'd like you to get out of today is to contribute, to fill in, to call BS when you hear it, and really be part of sharing, a broader set of ideas and experiences in this space. But DevOps has become an interesting topic to me, and something that I really didn't think about maybe 3 or 4 years ago. So first off, let's just start off with that term. Get some ideas here. Can anyone what would anyone in the room say? What is DevOps? What does that mean?
Continuous integration.
Continuous integration. What else?
Just looking at
so development, operation as a holistic thing. Yeah. What else? Okay, so I'll summarize that to say that it's not a noun, it's a verb, it's a way of working, it's a way of communicating, it's a way of tightening feedback cycles. Yeah. What else? What else comes to mind when people think of DevOps? System development environment. So, consistent. Yes. So creating a consistent development environment. Yeah. So agile. So the analogy was made between waterfall and agile. The same improvements that we got in developing software. This is a similar improvement over. I'm not sure what I guess separate having a separate operations function versus integrating it together has brought some of the same benefits that Agile has brought to actually developing software. So full responsibility. Yep. I would agree 100%. I think based on this feedback, I think you guys kind of know everything there is about DevOps. So could be a short seminar today. No, these are all. I agree with everything that everybody said here, and we'll talk a little bit about all of these. So my thoughts on it are, first, this concept of application development and system operations kind of combined together. Rather than separating them out and having silos of, you have your app development folks, you have your operations folks, and you're constantly doing handoffs back and forth, you're doing it as part of building the software. Building the software doesn't just mean writing the logic that implements the business functionality or implementing the stories that your product owners or your business analysts have written for you. It's It's also making sure that you get that piece of software deployed somewhere where it's useful and that it's actually running all the time. So I think for me, one of the biggest things is that it's a way of empowering teams. When you basically define the stopping point where a team's responsibility ends and it needs to go to another team for that to be carried forward, that's going to create delays, it's going to create handoffs, it's going to create times where you're just waiting on other teams to prioritize your work. And if your team is empowered to make the smallest change, fix a bug, or introduce a new field into your API, and the engineer who writes that code, who spends 15 minutes writing the code, 15 minutes writing the test code, can then spend 5 minutes deploying it to a test environment, and then once it's been certified, spend 5 more minutes deploying it to prod. That's a really powerful model. That's a model where you can take your own destiny into your own hands, and you can really ship things as quickly as you need to without relying on other teams, without putting in blocking points where other teams have to get involved. The other thing I've seen with DevOps is that it helps you increase your delivery speed. Again, because you're not waiting on other teams, because you are completely in control of things, you can actually see things come to life much faster. You can iterate much faster. I know that over the course of the last 5 or 10 years, the industry has moved towards models where it was acceptable to deploy once a quarter or once every 6 months. And now it's probably not acceptable to even deploy once every 2 weeks to production. The speed of business, the speed of change, the speed of what people's expectations are is much faster. And the only way, one way to get there, and I haven't seen teams that are operating in a non-DevOps model be able to ship new versions as frequently as you can in a model where you're doing DevOps. It's also why developers don't get time off. It's why they're on call, so there's some aspects of DevOps that are challenging from a how do we create a sustainable model for creating support for these systems when developers have day jobs, and then they're expected to respond when something bad happens at night or on the weekends. So some of the aspects when you think about a DevOps model, or if your team is working in a DevOps model, what kinds of properties might that exhibit? The first I would say is that when you're defining your deployment infrastructure, when you're defining how your system is going to get put out into production or put into a test or stage environment, that all of the things that define that are going to be defined as code. They're going to be treated the same way that application code is going to be treated. They're going to be scripts. They're going to be checked into source code control. We're going to have revision history on it. We're going to have code review on it. It's going to be treated. You're going to deal with system configuration and deployment configuration the same way you would your application code, because it's just as important as your application code. Without it, you don't really have a system. The second is that there's no separate team that is responsible for deploying and monitoring and making sure the system is up. So you're not looking to anyone else to solve the problems of the team. You're looking to the team to solve. The product team is going to solve the problems of the team. Another one that I've seen is that the team itself has to develop its own best practices around how they need to monitor that system. It's a little bit like Agile. I'm glad somebody brought that up, because in my experience, Agile is really powerful. It's clearly a better way to build software than Waterfall. We've learned that over the last 15 years. Within Agile, I feel like the best Agile teams actually refine the Agile process to how the team works best. Some teams like a 2-week sprint cycle. Some teams like Kanban. Some teams like more ceremonies. Some teams like less ceremonies. But if you try to impose exactly what Agile processes you want for a given team onto that team without their acceptance, without their understanding of what the value of that process is, it's not going to work out. Does that ring true to people? Have people been in situations where you've had a Scrum Master who just wants to follow the book of Agile to the nth degree? How well has that worked? It doesn't in my experience. And so with DevOps, I would look at it the same way. There are some core principles of DevOps that are like core principles of Agile in terms of quick feedback, quick turnaround, continuous integration. Somebody mentioned that. You pretty much can't have DevOps without CICD. CICD is not just DevOps. I mean, that's not all it is. But CICD enables you to have a DevOps model on your team. So, much like Agile would say, you got to have short iterations. You got to release things frequently. It doesn't tell you how frequently. It's up to your team to figure that out. But DevOps is much the same way. You need to allow the team to say, because people on the team are the ones that are going to get woken up by a support call, they're going to have their dinner interrupted by something happening, you need to let them figure out the best way that that's going to happen. Is that going to come through a Slack message? Is it going to come through a text message? Or do they want to be called on the phone? How do you sit down as a team and figure out how you want to deal with that? We've mentioned this already. You're not going to have a separate operations group, and this is a big shift for people that have worked in the industry for a long time. IT organizations that are supporting production systems have normally had pretty large operational support organizations. That's what they do. They're the sort of the serious people with the briefcases and the developers have always been the creative types who are constantly building crap that breaks that the operations people have to support, quote unquote. And at least that's my observation from being one of those development guys that makes things that breaks. And I think what we've seen at Target, what I guess is happening in a lot of other places is that those centralized operations teams are getting smaller, and that work is getting pushed into the product teams themselves. And lastly, as a developer, it's not good enough anymore to just be a programmer who likes to program logic, who likes to use data structures and algorithms to solve business problems. You have to be able to do more than just that anymore. We're being asked to do more, and if you go look at job boards and job postings of startups, large companies, mid-size, it doesn't matter. Everyone's looking for people that can write software, solve business problems with software, but also do the job it takes to get that software deployed and to make sure that it's running all the time. And that involves a lot of different skill sets, and it oftentimes will take a team of people where people have different specialties, where they might have strengths in troubleshooting, but in general, if you're going to be on call for a system, you've got to have a basic level of understanding of how to identify where the problem is and get it resolved so that we can minimize the disruption. So these are all relatively new for people that were purely analytical thinkers, coders, people with computer science backgrounds who were good at solving problems and thinking abstractly. So to kind of ground the rest of our talk, I wanted to describe a few, just as examples of when we talk about DevOps, what are we talking about? I think everyone, I loved the feedback because it was all about different things. It was about process, it was about communication, it was about deployment pipelines, and it's really about all those things. So to just sort of ground them in some kind of real-world examples of things that I see in my day as what I would call DevOps. And if anybody thinks any of these aren't DevOps, would love to get would love to hear about that. So here's an example of something you might hear. Today I'm going to write an Ansible script that defines a virtual machine where I'm going to deploy an instance of our Ruby on Rails application. So, I'm going to be scripting in a language that enables me to define what that machine looks like. And so I need to know about the properties of the Ruby on Rails application, but and I need to know about a Unix system so that I know how to set up the logging, so that I know how to set up the processes to run at the right time. I need to be able to test that deployed instance is set up the way I think it should be. But this could be a common activity, is that and this could be an application developer doing it, or it could be somebody who is an expert at system admin, is really more of a operational person. Another activity, and this comes to the notion of CICD. So Jenkins and drones are build applications that really support the CICD function. So if I'm on a new team and we're trying to get our build server up and running, I'm going to probably want to script out what that Jenkins configuration looks like, so that if our Jenkins box ever has a problem, we can quickly rebuild it and be back up and running. 10 years ago, people would just manually install Jenkins on a server and do a bunch of hand configurations through the web UI, and then if that thing ever went down, you'd have however many days of outage where the team couldn't build or deploy because it was hand configured. So moving to a model more of DevOps where the configuration for that build server is also scripted, so that at any point in time we could say, hey, tear down our build server, let's move it from this cloud provider to this other cloud provider. We should be able to do that in a matter of an hour instead of days. Another example. So use a tool like Chef. Chef and Ansible are common tools in terms of setting up infrastructure, setting up servers. But this time, we need to set up some infrastructure that allows us to install a Splunk environment. Has anyone here used Splunk or familiar with Splunk? What does Splunk do? Yep. So Splunk is a great tool that lets you send logs from your systems to a central place, and then it builds some really nice reporting and alerting on top of those logs. So something like that is really common and really essential for most systems. And so getting that set up, again, it's not going to be the responsibility of a centralized team somewhere. Sometimes you can buy services like this, and when you can do that, that's useful. But oftentimes it's the team itself who's saying, when they're getting off the ground and getting all the things set up, hey, we need a log aggregator so that we can get useful information out of our logs. So another type of DevOps activity. And then, of course, everyone's favorite is responding to alerts. So it's 11 p.m., pager duty goes off, you get a text and that says, hey, response time, the 95th percentile for our API has gone over 5 seconds. And so somebody needs to hop on and say, hey, what's going on? Is it our database? Is it one of our back-end APIs? Are we having some issue with an instance that I need to sort of restart that instance or rebuild it and delete the bad one? But these are some examples of things that would be typical for teams that I work with at Target and are indicative in terms of what I think about what DevOps means kind of on a daily basis. And it kind of shows you a little bit of the variety of everything from CICD to log aggregation to responding to a production issue. How do these examples, are these examples similar to what people in the room?
I think you buy another.
Got it. Okay, so that's an interesting point, is that, so you mentioned PCI, and there are some things that are critical, whether it be security, where you do need, there's still an evolving space here, and that's a great point, is that when there's sort of a perceived or real risk to the business that requires you to have some separation, that's where this model, this model, it may not be purely clean in terms of being able to say the app team itself can do all this. So thanks for bringing that up. That's great. Yeah. Yeah, great point. So he pointed out that there's a lot of complexity. There's a lot of different things here that you need to be an expert on to do it properly. And so what he asked was, do you find that there are certain people that just gravitate to this and sort of stick to that work, or do you find that everyone kind of has to learn everything? And the answer is, It depends on the team. It depends on the people that you've hired. I think I've seen both. I've seen generalists who are full stack and they like to do all of this, and so those are more rare. What I find mostly is that you sort of have your people that like to do this kind of work are embedded within the app team. They might dabble in doing API development, or they might dabble in doing front-end web development or mobile development, but their passion is really kind of the infra, the systems programming, the Unix sort of centric way of thinking. And so they tend to take on this work more than, and then there's the people that love doing the business logic and love doing the front-end work. So I think that to be on product team, a modern product team, you have to have some knowledge of what all these things are, because if you're deploying code and something happens with the drone server or the Jenkins server, you want to be able to go look at it and at least troubleshoot it to the point where you can bring it to the person that is the expert in that and say, hey, our Jenkins box has run out of memory, and can you help us get it on a bigger box? That's, I think, so, but it's a great point, is that some people are going to go deeper on this, and some people just need to know it well enough to be able to maybe self-serve and troubleshoot some small things, but if they need to, they can go give that person the most context so that we can quickly get it resolved and move on. Yeah, so that's a great point. And so the way I'd recap that is to say, you're still going to have experts. You're still going to have the person who's an expert on Ansible or who's an expert on Chef. It's good to know enough to go in and sort of see where the issue might be, and if it's a simple fix, you realize, oh, the Java settings on this Ansible script aren't correct, and people should feel. One of the things that DevOps, I think, forces you to do more than non-DevOps models is to be out of your comfort zone a little bit and to sort of say, hey, what's reasonable here? Oh, okay, make some assumptions, but then get that do a PR. So that you can make the change yourself and you can learn some of these things, but through that feedback process, because it's code, you'll want to get it peer reviewed and you'll want to get it checked off by somebody who can confirm that your assumptions are correct. It's fluid, but I think you will find people who are going to be experts on certain things, and you are going to probably have to go, in many cases, go out and get the person that is the expert on that thing. The other point is that your team may not even know about some of these things without that expertise. So you do want to make sure that as you're bringing people on, that they're familiar with the repeatability, they're familiar with how to get things deployed in the cloud, what sorts of things you're going to want to stand up as a matter of practice. So, kind of again a little bit more of a meta topic, but why do we need to have DevOps? What is it that it's providing us, or why have teams moved to these models? There's a couple of things here. One is we've increasingly gone from most people thinking of software as a shrink wrap piece of something that you go to CompUSA to go buy and put it in a hard drive or put in your CD-ROM and install, and it just runs, right? Software is almost universally now becoming a service, which means a lot of different things. It runs all the time, and we'll talk more about what software as a service is. But that's what I would, show of hands, who here is working on something that's software as a service, something that's running continually on a server somewhere, or like needs to be up. So I'm surprised. It's about half the room, maybe 3/4 of the room. So with software as a service, people, systems, customers, businesses are relying on that 24/7. It's just running all the time, and it's doing something valuable most of the time. Because of that, well, first of all, outages are costly. So if it's an important system, if it's down, if it's not functioning, it's dollars. And so people tend to get antsy about that, and people tend to want that problem to get resolved as quickly as possible. As I mentioned, speed of delivery is critical. It's becoming more critical for us to go from idea to deployment as fast as possible, because we're trying to validate our business ideas. People want to invest in businesses. They want to validate whether the idea is good or not. They want to make adjustments and course correct quickly. So that's extremely important, and it requires a DevOps model to do that. Who here just by show of hands, familiar or heard the term a product model, product development model for developing software? Does that term, like, is that a thing? It's a big thing at Target, and I don't know how broadly, I think the concept comes really from software product companies. So think about Microsoft, think about Facebook, Google, Twitter. They're building software products, and so they tend to think about their creation of software as the creation of a product, whereas non-software companies traditionally have thought about software as a cost center, a project-based thing where you have a start and a finish. You usually have a Microsoft project plan put together, and what am I doing the first month? What am I doing the 6th month? Number one, that doesn't fit real well with the agile model. These long-standing projects that have a start and an end is okay, but the main difference between a project and a product is that a successful product continues to get evolved and refined. It doesn't. You don't really end a product until your customers tell you this product's not useful. That's kind of the end of a product. Whereas a project kind of says, "Yep, we're finished with this thing, and now we can just sort of, wipe our hands off and walk away from it." And one mind shift away from that project model to the product model is that the product team is responsible for bringing the product to life and making sure that it's vibrant, making sure that it's going in the right direction, making sure that it's evolving. And so Devops really helps with that because it's the team's responsibility to ensure that that product is alive, functioning, and running well. Does that make sense, or is it just kind of a bunch of words? I've come to kind of really appreciate this in the last few years, but it's sort of a subtle difference, and I think I think you're going to probably see more and more companies moving to a software product model because it's got a lot of benefits. Yeah, so that's a great point, Brian. So the ownership piece to say, my job, the responsibility silos to say my job is just to write Java code, and when my unit tests pass, I'm done and I can go on to the next thing. And it's identifying the fact that that's not valuable enough, right? Having code with passing unit tests doesn't necessarily get the customer what they're looking for, or the business what they need out of that. You've got to take it across the finish line, and you've got to care whether that thing is running and whether it's responding fast enough. And it's sort of saying, does this piece of software have value in the world? And if you embrace that and you take the ownership for that, you're probably more in a product mindset than you are in a siloed project mindset.
One other.
Sure, great point. So kind of going to that root cause of the outage, that it used to be that you'd have hardware failures. You used to have a disk failure. You used to have a networking failure at the hardware layer. And because we have so much capacity available to us in the cloud, public cloud providers, it's very easy to, if there is some sort of action, at the end of the day, you could have a hardware failure, but the reality is you have basically infinite scale. So you basically say, oh, that server is having issues. We're just going to take that offline and instantly have more capacity. And so where you tend to have outages these days is software-related outages where, I didn't fully understand what my system would do if my Mongo response times all of a sudden tripled. Like that introduced a cascading failure, which resulted in this other bad thing happening. And so, those sorts of failures are more common than the traditional disk outage or hardware level failures. So great point. So a little bit about software as a service. We talked about that. This can be an API, this can be a website, or even a platform that you're building software on. It's usually available via the internet, like web apps. You deploy it and manage it by the product team. We've gotten to a world where we talk about what's your availability, and you just quickly go to how many nines can you support, and that's sort of your percentage of uptime. It doesn't take a long time, and a lot of places won't even consider, anything below, 4 nines as being acceptable anymore. You've got to, and that doesn't really give you a lot of time where your stuff can be down in a given year. I forget how many hours it is to be at 4 nines, but it's only a couple over the span of a year. So you really can't afford to have planned outages in the modern era. Customers and businesses don't want that. You want to be able to service your customers whenever they want to use your system. So these all feed into the desire for that. You also want to make sure that if you experience success, if you experience periods of high demand for your product or for your service, that your system responds to that. That you're resilient to increases in traffic. We talked about many of these already. The self-sufficient teams. I think one that's important and I think sometimes might be overlooked is that because when you think about your operational and your setup as a coding task with a scripts and programming around setting up those environments, you should also, anytime you're coding anything, you should be thinking about how do I test this code. And so what's cool about many of these platforms is that there are associated test platforms that help you test out that your platform has been created successfully. So you write a script, it sets up all of the settings for the VM, and then you run a test against that VM to make sure that everything is in place the way you expect it to, and maybe even hit the endpoint and ensure that, yes, I set up the server, the memory settings are correct, the disk settings are correct, and everything is working as I expect. Okay, so another question that people sometimes have when they're moving to DevOps model is, how much am I going to invest? How much of my overall development time is it going to take me to do DevOps work? And the first thing I would say is, as I kind of got into this space, I kept reaching points where I say, hey, at the end of next sprint, we're going to be done with the DevOps stuff. Like everything will be set, and we can just, we can focus on the real work, the business logic, and the stories, and the product owner can, have all the features that they want. That has never happened in 3 years. I finally stopped saying we're going to be done with DevOps and DevOps work in terms of daily activities of scripting, of fixing things, of troubleshooting problems. What I've seen over the course of the past 3 years, and it doesn't matter whether it's a 4-person team, it doesn't matter whether it's a 25-person team. About a quarter to a third of that team's effort has been very consistent. Focused on DevOps-related activities. So I'd really be curious to cross-check this, more broadly. Can anyone comment on, in your teams, if you're working in a DevOps model, have you had significantly different experience from this? Did you hit DevOps Nirvana and you finished it in April and you've walked away from your DevOps scripting and coding and never had to touch it again? Or have you had more? I mean, if you're on a platform team, you're probably going to be doing all DevOps-y kind of work. But yeah, so the support and so what I would say is like supporting it yourself is just like that's just going to happen. I'm saying like when engineers come in the morning and they look at what they sit down to work on something for just sort of during your normal day job. So 8 to 5 type work. How many people, what percentage of your team, 8 to 5, the outside the hours, the support stuff, that's there. So, I'm considering this more like coding and scripting and doing things that are either supporting the deployment process or creating dashboards or setting up infrastructure or fine-tuning the infrastructure you have or, taking learnings from an incident and converting them into better platform support, those sorts of things where you're like, your day job is involved in this kind of thing, not off-hour support stuff. That's a good clarification.
I have this easily.
So great point. I think because my background was app development, I was basically ignorant to the amount of work that this was happening continually. So it's an appreciation for the complexities, the challenges, even though we have platform software that is amazing. It allows us to build a lot of crazy things. It's evolving at the same pace as the technologies are on the programming side, on the app development side. So it's there's a lot of factors at play, but there's it's always been something in the siloed model, in the prod support model, where that's a separate operations group. All the work that was going on there, all we saw was I got to ask these guys to get my thing deployed, and so it was you just didn't have an appreciation for the kinds of things that were happening there. So that's a great point.
The layer under the app, a good amount of work.
That's
Does that evolve?
That's a great point. So he mentioned a few things there. He mentioned you're running on you're always running on some sort of software that your system depends on, whether it be OSs, whether it be application servers. These things have vulnerabilities that need to be patched. They have fixes that need to be applied. That in itself is just an activity that needs to happen. And it's not necessarily sexy work, but it's necessary work. And so how do you make that process as fast as possible? HTTPS certs, that need to be updated. There's a whole slew of complex things that just exist. Even if you don't write another line of application code and your code is just sitting there running, you need to keep an eye on these things. Arguably, you could arguably have a successful system running for a couple of years that doesn't have API or coding people working on it, but needs continual DevOps support. So if you're really going to shut the lights out and low, keep your DevOps engineers around longer than your
Most commonly
programmers.
defined that you hire.
Sure. So yeah, as you learn about what data is useful to collect off of this running system, that's going to be dynamic just like everything else, and you need people to introduce those metrics into the system. There was somebody over here yeah. That's a great point. And so what he was saying is that bringing the DevOps role within the team actually elevates all the points and the parts of operations that are important. And those things can actually influence your writing of the system code. If it's important for us to be able to access certain metrics off your system, and that would require the application developers to emit those metrics out of the system, they're going to get a deeper appreciation for why that's useful, because they've got an engineer sitting next to them saying, hey, I want to create a dashboard that shows our Mongo response times or our Oracle response times. That app engineer can better appreciate why that's useful, work with that operations person to build it in a way that we're collecting the most value from it. So that's a great point, because a lot of those things are never going to come from the business people, the product owners, the people that are writing the stories, unless you've got a technical product owner that is dealing with the platform. And I don't know how common that is. Does anyone work in a model where you have a non-engineer or some sort of business person who's focused on defining what stability looks like, defining what operational support looks like? Because it's generally not something that the business folks get involved in, but they certainly need to know about it and at least carve off a certain amount of time to be able to support that.
Make a comment about that.
Great. So great point. There's a lot what he mentioned there, but what I'll recap is to say, having the product owner sit collaboratively with both ops and app development to understand both sides of it, and then to think holistically from business to customer, all the things that need to happen. And it's up to us on the technology side to convert something like uptime and operational readiness into what's the business impact if that thing is not done, right? I mean, just telling the product owner, hey, trust us, we need to have this monitoring in place is not good enough. We're going to be better off if we can convert that work into some business value that the business person can understand. And I think having that open communication, sitting together, and having all parties involved in understanding the full context is one of the best ways to do that. So, all right, we've been here almost an hour, so we'll take a break, and then we'll dive into some topics around how can DevOps. This goes back to the point of if your app developers are more aware of operational aspects, how does that affect their job? How does that affect the way they architect the system or the way they design their software? So we'll dive into some more of those topics, but take about a 10-minute break.